Today we have something a little bit different for us to look at. This is a CCM bicycle, and the owner tells me that it dates from 1950, and it is equipped with a BSA 3-speed hub. Now BSA, which is Birmingham Small Arms, is a manufacturer that dates well back into the 19th century. As the name implies, originally they manufactured small arms, rifles and so forth, and then in the 20th century they got into bicycles and bicycle components, and then motorcycles, and I think along the way they built some cars as well. Anyway, this bike has the BSA 3-speed internal geared hub. They made this hub up until the mid-50s. I believe 1955 was when production ceased on it. Anyway, we've got a bit of troubleshooting to do on this one. There's some issues with it. One of the issues is that when the bike is rolled backwards, the wheel locks up, and rolling forward, it wants to act like a fixed gear. In other words, it carries the cranks along with it. So something's going on inside there. It's almost acting like it's locked in 2 gears at once or something. Anyway, looking online, there is virtually no information about this. Very little discussion on it. Any discussion that I did find led back to a manual that was published in 1949 for this hub. So the service manual is sort of a schematic drawing of the internals, along with some instructions on how to service it. But I can't find anything on YouTube where anybody's actually torn inside of one of these things and check them out. And of course, being out of production for over 60 years means that, you know, replacement parts will be pretty much non-existent. If they do exist, they're packed away in a drawer somewhere, or long forgotten and long lost. So anyway, we will carefully open it up and investigate what's going on with this hub and see if we can troubleshoot the issues. Alright, so now we're going to follow along on our song sheet here and proceed to strip this thing down. Along the way, I'm going to do some comparisons and contrasts with the Sturmey Archer design. There is substantial differences, although there are some similarities. One of the differences is that the indicator spindle protrudes right through the non-drive side on the BSA hub, whereas it does not do that on the Sturmey Archer. Also, with the Sturmey Archer hub, the indicator spindle's position in first gear would be fully retracted, second gear the middle position, and third gear the fully relaxed position. This hub is exactly the opposite. Okay, right now with the indicator spindle fully retracted, it's in first gear, second is the middle position, third is the fully pulled out position. Now, the reason that this protrudes through is that that's how we set our adjustment, our shifter adjustment. Now, when the bike is, or when the wheel is in the bike and the shifter is connected, the shifter is adjusted by adjusting this so that in second gear the end of this rod is flush with the end of the axle in second gear. In first gear, in this position, it is supposed to have 1/4 of an inch protrusion. So we will check that with our handy dandy caliper here. And we see that we're just a shade under Not sure what the tolerance is, but it's pretty close. You know, 24.247, so it's pretty close to a 1/4 inch. Probably close enough to work. Alright, so doing some comparisons with the Sturmey Archer. The Sturmey Archer 3-speed, the internals are unscrewed from the hub shell and removed as a unit from the hub shell, whereas in the case of the BSA hub, it's opened up from the non-drive side and the internals are removed first from the non-drive side and then from the drive side, so they do not come out as a unit. Another difference is that the threading on a Sturmey Archer hub, the axle thickness is 13/32 by 26 threads per inch. The BSA hub, the axle is a 3/8 by 26, which is, you know, sort of the standard size for inch standard hubs. So while one might be tempted to replace this nut with one from a Sturmey Archer, because, you know, new pristine hubs for the BSA are not readily available, one would find that the 13/32 hub from, or nut from the Sturmey Archer will thread on, but we see it's a very loose, sloppy fit, and we don't get proper thread engagement. So while it might be tempting to replace the nut with a Sturmey Archer one, don't do it, because you will strip the threads. You must use a 3/8 by 26 nut. Okay, so we're going to open this hub up from the non-drive side, starting with two 15mm cone wrenches. Remove the lock nut and cone. Alright, so now we take the end cap out. There's a special tool for this, but I don't know if anybody has one around anymore, but the flats on the axle will engage an adjustable wrench. And this is left thread, so clockwise to remove. Because the ratchets are engaging it as we go, we have to turn the wheel. Okay, so we come hard against there, turn the wheel a little bit, then we get another few more degrees of rotation. That all goes back to whatever is going on in the hub that locks it up while pushing it backwards. See that? Turn the wheel a bit. We got a bit of free motion. Okay, so here we see that the pawls are actually on the inside of the end cap, and the ratchets are on the gear carrier, which is, of course, the reverse of the way things work in a Sturmey Archer. So now that the end cap is out of the way, the next step is to remove what they call the actuating nut. And it's also a left-hand thread. And it is a 5/8 inch. So clockwise to remove. And once that's out of the way, the theory goes that we should be able to remove this unit from the left side of the shell. And the other side drops out of the right side of the hub shell. So now we have this thing apart. Let's take a look at what makes it work. Okay, looking first at the hub shell, we see this is the non-drive side where the end cap screwed into. And I don't know if you can see it or not, but inside over in the drive side is the ratchet ring that drives the hub shell in second and third gear by means of these pawls, which we will explain later. So running through the components of the internals, we have the driver, and we see on the driver we have ratchet notches cut around the circumference and on the end face of the driver. And those ratchets engage with the pawls first on the inside. Okay, so those pawls that face in drive or are driven by these ratchets on the external side. And down inside there we see we have dogs facing inward, which are engaged by these ratchets on the end of the driver. And that is for when we are shifted into third gear, and we'll explain that later. Here we have the sun gear. Notice that the sun gear is about twice as long as it would need to be to engage the planetary gears, and that's because this gear carrier unit actually slides back and forth on the sun gear. Alright, so just to give a rundown of what goes on here, when the indicator spindle is all the way in the relaxed position, alright, this gear carrier is hard against the non-drive side, and when that happens, these ratchets engage the pawls. Okay, so that's engaging the pawls on the end cap. So when the ring gear is driving the planet carrier at a reduced speed, that's what gives us our first gear. So now we have the internals assembled, and first thing we'll look at is when the indicator chain is all the way in. That's allowed the gear carrier to move all the way to the non-drive side, which engages these ratchets with the pawls in the end cap. So as we turn the driver is driving the gear carrier, which, by the way, having moved endways, the first thing that happens is that these pawls move out of engagement with the ratchet ring in the hub shell. So these pawls are not driving the hub shell. So as we rotate the cog, we see that the planetary gears are giving us a gear reduction. Notice how the ring gear is outrunning the end cap. Alright, so the end cap being screwed into the hub shell, that's what's driving the bike forward. So we have our gear reduction, and that's first gear. when we shift to second gear, all right, so we pull on the indicator and we move the gear carrier endways, and that actually pulls these ratchets out of engagement with the pawls in the hub shell. So this is no longer driving the hub shell. All right, so and these pawls move back into engagement. They engage the ratchet ring in the hub shell. So when we rotate the cog 1 revolution, that's rotating the gear carrier 1 revolution. These pawls driving the hub shell. That gives us a 1-to-1. That's our second gear. When we move our gear selector to third gear, we pull the gear carrier all the way over until, remember those ratchet dogs that we showed you on the end of the driver? That actually engages them with the gear carrier. So now we have the driver turning the gear carrier. The planetary gears are overdriving the ring gear. So now we have the ring gear turning faster than the input cog, and these ratchets, or these pawls driving the ratchets in the hub shell. So that's our third gear, or an overdrive gear. Okay, in this segment we get to the fun part, the reassembly and the troubleshooting portion. And I've completely disassembled the gear carrier to inspect the planet pinions and the assembly itself. I see that the pinions are in good shape. The ratchet teeth are all sharp, and doesn't appear to be any appreciable wear on that. The dogs on the end here that engage the driver in third gear also appear to be in nearly pristine condition. One of the issues with this hub was that the last time it was assembled, it was packed with grease, something like a number 2 grease, which is too stiff and viscous for these hubs to operate properly. British hubs prefer to be oil lubricated, and the suitable oils cover a pretty wide range. You could use like a number 20 motor oil. I use just a base oil, like an 85 neutral, no additives. Makes for very good lubrication for small parts like this. So now we're going to assemble the planet pinions in the carriers. I'm just going to put a little dab of oil in the pinions to lubricate the pins, and we see on the instructions that the beveled end is supposed to face the non-drive end. So we'll carry on with the assembly. And the pinions themselves they're symmetrical. It doesn't matter which way they go in. Now to complete the assembly of the gear carrier, we'll run a little bit of oil around the ring gear here. And drop it on there, engaging the planet pinions. Flip it over, and we complete the assembly by installing the circlip. Make sure it's in the groove all the way around. And that's done. Next, we ensure that the right-hand cone is installed correctly on the axle. The right cone is not adjustable. It screws down hard against the shoulder, and there is a spacer. There's a couple of different size spacers that were provided for these, and those spacers make for a critical dimension, which we'll get to in a minute. But anyway, we screw that down tight, and then the lock nut will be locked down on it. We have to clamp the right hand end of the axle in the vise because the left end does not have axle flats. Alright, it's round. The anti-rotation washer goes on the right side only, and we can only grip the right side in the vise without damaging it. And torque specifications are not given, so just until it feels right and tight. So now we're going to install the driver, and while we mentioned that the internals should not be grease lubricated, the cup and cone bearings should be grease lubricated in order to properly lubricate the bearings, for number one, and also to help contain the oil within the hub. So we'll drop the driver on to the bearings. Make sure it's rotating freely. Now we get to the critical dimension part. The measurement from the tip of the drive dogs to the end of the sun gear is supposed to be 0.913 inches plus or minus 0.003 inches. So I've set the caliper to 0.9130, and looks close enough for around home. Now we get to the part where we actually find the issue that this hub was having. You see down through, we're looking from the non-drive side down to the drive side, and on the other side of the hub is the high-speed ratchet ring. And if you look here, there's a smooth ring portion where the pawls run. Try and get the light on there. Okay, so the pawls run on this smooth part of the ring when the hub is in first gear. In second and third gear, the pawls on the carrier engage the ratchets. I'm not getting the light on there too good, but anyway, you can see the ratchets where the pawls engage in second and third gear. So now I'm going to install the gear carrier into the hub shell, and when I put it in, the pawls rest up against the high-speed ratchet, and in order to get it to engage, we have to depress the pawls from the back side. All right, see what I'm doing. Okay. So now we've got the gear carrier engaged, and we see that when it's all the way in, that's the third gear position, and out in the center position we're still engaged with the pawls. That's the second gear, and then when we pull it out a little further, okay, we're running on the smooth part of the ring, and there's no drive action between the gear carrier and the hub shell. And that's how we achieve first gear. Next stage in the assembly is to install the driver. And once that's properly in place, and we're still getting sliding action on that, so that means that the pawls are still have not slipped off of the ratchet ring. Now we install the actuating nut, which, as we remember, is a left-hand thread. And once again, no torque specifications are provided, so just go till it feels right. Alright, so now we'll just check the function of it here a little bit. So now With the indicator spindle all the way in, we see that we're in first gear. So we can turn the cog and the driver, and notice that the ratchets are not engaging the hub shell. We pull on the indicator until the end of the rod is even with the end of the axle, and now the ratchets are engaging. Okay, so we're driving the hub shell at a 1-to-1 with the cog. Pull it all the way, now we're in third gear. And now the hub shell is rotating faster than the cog, and that's third gear. So everything's working as it should. So I just realized that I forgot to mention what the issue was that was going on before. So it turns out that the last time this hub was assembled, the step where the pawls were depressed to make sure that they engaged the high-speed ratchet ring had been skipped. So the pawls were actually butted against the high-speed ratchet ring and would not engage it. So that's what was going on. They were jammed up against. There was actually wear marks on the sides of the pawls where it had been wearing against the ratchet ring. So that's what was going on, and that's why it wasn't working. All right, so now we're ready to install the end plate. And remember that this is a left-hand thread. The driving action of first gear will actually tighten it into the hub. So if you don't get it properly tightened the first time, you'll find that the bearing adjustments will go out as it tightens in. You'll have to take up the slack in the bearings. Alright, so now we drop in the bearing retainer. And the cone and lock nut. And this is just like any other bearing adjustment. BSA says in the instructions that with the lock nut and cone tightened down that you should feel a very slight perceptible play at the rim. So adjustment will be trial and error till we get there. Okay, so I got a little bit of perceptible play, actually a little bit too much, so I'm going to work at that and take it out. Alright, so now we've got the end cap on. So now we see that we have all three gears. Alright, so with the indicator relaxed, we turn the cog, and see the hub shell is rotating more slowly than the cog, so we got a first gear. Pull the indicator until this is flush. The hub rotates 1-to-1 with the cog, so we got second gear. Pull it all the way in, or all the way out rather, and we have our third gear. So it's working like it should. We'll do a final adjustment on the bearings and install it in the bike. So the hub is installed in the bike, and I've tested all three gears are functioning. For lubrication, as you saw, I was adding a little bit of oil as I went when I assembled the parts. The lubrication requirements aren't specifically listed, other than to say light machine oil and about half a teaspoon should be added once a month. It does not say how much should be put in the hub originally, but you know, I've put in a little bit, and seems to be working pretty smooth. Anyway, we run through all three gears, and everything's working like it should. The original issue where the wheel was locking up, rolling backwards, is gone. And it also freewheels, no longer running like a fixed gear. I can't road test it yet because we don't have brake cables in it, so, but it's working in the stand, so quite confident that it will work on the road, and good for many more years of service. Thanks for watching.